Good morning. Thank you for taking the time to join us at OEG Live. I am Alida Lewis, Head of Temporary Power at OEG, and I am here to talk to you about planning, safety and setup of temporary power solutions. So to start with, we're looking at why temporary power matters. Temporary power enables critical activities, reduces risk and maintains continuity on the wind farms. So we provide support through a few stages of wind farm life cycle. The largest deployment tends to be during turbine commissioning and construction. We also provide support during substation commissioning, cable testing, and then at the O&M phase for both planned and unplanned turbine downtime. So we have here up on the screen a number of challenges that we see through the industry. So we're going to start over at the top left with our space limitations. We're providing generators to the temporary power platform, to the TP platforms, and often there's a lot of work that needs to be done, a lot of scopes happening at the same time, and then fitting the equipment on is key. Weight restrictions. As we've moved into recent years, we're starting to see more and more requirement for the 14 and 15 megawatt turbines. This leads to the generator requirement being slightly larger, and we're looking at bigger machines. And that's often paired with a trend where we've seen the working load limitations of the davit cranes reducing, and we're more often working with a 1 ton limitation, or requiring larger, more expensive SOVs to come in and support with generator movements. Tight mobilisation windows. We have to ensure that all equipment is ready and it is delivered in time with project milestones and meeting load-out schedules. Remote monitoring. More and more the wind farms are further offshore. There's less connectivity, and the requirement to monitor the generators remotely increases to ensure that we're not wasting resource and sending vessels to do checks unnecessarily. Offshore conditions. It's a harsh environment. We're using the generators quite far offshore in a few different climates, especially over in APAC, and also off the coast of the US we see some particularly severe weather conditions. So the equipment needs to be robust to withstand this and to continue to deliver and perform as the client needs. Evolving project requirements. Temporary power is never plan A. It's not something which is kind of a desirable outcome for, especially during construction. And we understand that, and there is a need to be flexible and to be able to adapt and deliver as the client needs. So then looking at what experience has taught us, it's not just about the equipment, there's a lot more to it. And these are 4 kind of key takeaways and lessons learned from a kind of planning and design. So looking at early engagement, project requirements are rarely standard. The early engagement allows for bespoke designs, bespoke planning, and it allows us to work with our clients to provide the product that works rather than a product that is adequate. So safety by design. Safe often means simple, and we look at items such as a kind of single lift setup. That's minimizing the lifting exposure. There's less lifts required, and so there's less risk. Similarly, refueling. Designing integrated fueling setups using the OEG CTVs allows for a safe transfer of fuel and safe systems of work to be used. Reliability through maintenance. Maintenance matters. We've got to ensure that the generators are working well to provide the service that is needed, and allowing the service providers such as OEG time for upkeep of their equipment increases the uptime that is provided to the projects. And then dedicated scope management. We know plans change, we know requirements change, and having that dedicated management, both on the client side and also on the supplier side, allows for early comms and improved delivery and an improved working relationship. then to look a little bit more about what OEG solutions are. So we've been working in temporary power since 2013. We've supported approximately 55 projects in that time, working in Europe, the USA, and also in the APAC region. Our kind of key areas at the moment, we're doing a lot of work in the US. We're providing to all of the current wind farms under construction, as well as some future works coming up. APAC, we've been very involved with the Taiwanese wind farms, and more recently we've moved into South Korea and Japan as well. So the generators, we've got a global fleet. We're an owner-operator, and we own approximately 480 generators at the moment. These are offshore ready. We bring them in from our suppliers. We modify them in-house and add some adaptations to ensure that they're best suited to the offshore environment. And we offer the complete package, not just the generator, it's the fuel tank setup, the cabling, the remote monitoring, whether that be a 4G system, a satellite system, and any other kind of adaptations that are required, whether we're looking at 400 volts or 690 volts. So our personnel and project expertise, we have a proven global delivery. We have a strong group of technicians that are all certified and experienced within our operations. At the moment, we've got approximately 85 technicians working globally. The CTVs, so at OEG, we've got a fleet of 15 CTVs, many of which have been designed with temporary power in mind, with rapid fuel transfer, larger storage tanks, etc., to allow us to give that dedicated support to the scope. Okay, so now just a little bit of a case study looking at one of the scopes that we delivered through summer 2023 into spring 2025. So it is, I'll call it NNG, I don't want to butcher the pronunciation for the Scots here. So the requirement was to provide temporary power during construction. It started off as a smaller scope and there was a growing need, and come the end of the project we had delivered 54 generators, including a 120 kVA generator, a 2,000 litre mountable tank, and also the 690 volt transformer, as you can see in the image there. So we provided a stacked setup. It is something that we've been doing for a while, and we're constantly evolving. This allowed, when we move into the mobilisation, this allowed for 4 generators as complete packages to be loaded onto the 20-foot flat rack, which could then be lifted to the installation vessel in a single lift, with the individual generators again then lifted in a single lift onto the TP. All of this is minimising crane time, which is expensive. It's also minimising the number of lifts and reducing the risks of personnel undertaking those lifts. So then as we move into the kind of service and operation, we provided a comprehensive service scope. It included planned maintenance. We had a team on shore who were monitoring the generators remotely. They were monitoring fuel levels, service hours, and ensuring that was all scheduled in ahead of time to minimise any interruption to the client, maintain uptime, and ultimately maintain a good level of generator uptime as the client needed. So similarly to the mobilisation, the demobilisation, the generators can be lifted in a single lift. For this project, the demobilisation was undertaken via an SOV. And so again, we're kind of looking at that minimised risk and less lifts. I think we've talked a bit about equipment and how we're doing things. The one thing that is important is projects wouldn't happen without people. And so we look here, we've got a dedicated delivery team, and that included your shore-based expertise, where in the back office we've got the project management team, our technical team, and HSEQ, who are all supporting the delivery and ensuring that everything is going well, and any issues that happen are well resolved, and we can have open comms with the client. We then, On the ground at the client's office, we had an onshore operations team. They were working on the day-to-day planning, the day-to-day workings, controlling our work scopes and monitoring the equipment to make sure that we had that service campaign well handled. And then the technicians. We had multiple technician teams who were offshore every day doing the work. They're the ones on the tools, they're the ones who are keeping the generators running. And I think that's important because it's when things are going smoothly, if the generators are running, it's an easy job. They are skilled with fault finding. If there are issues, equipment does I think keeps us all on our toes sometimes, and the technicians have done a very good job at resolving issues and doing that fault finding and rectification work. And then to complement this, we had 2 CTVs that were operating for the duration of the project out of Montrose, which were providing dedicated temporary power support. And these vessels worked very well. You can see, I think, the Victor out there pushing onto the wind farm. We had a very nice setup. It worked very well, and I think that dedicated vessel provision allowed us to do the work that was needed to maintain the 54 generators that were running, which went very well. And all together with the kind of bits that we've looked at on this LNG project, we provided quite a large-scale operation, and our client was very happy with how things worked, and we had very positive feedback. So I think it shows how when you look at the turnkey solution, it all comes together very nicely. And then a little bit about the future. What's next? I think a lot of the work and a lot of the deployment for temporary power tends to be diesel generators, which isn't always I would say it's a bit of a kind of secret of the industry. It's not desirable. And so we're looking at what is next. We've increased our deployment of hybrid in the last year. We now own and operate approximately 40 of these power packs that you can see here on the screen. So these these provide for the permanent power consumption and are supported by smaller generators. So you can see the yellow box there is the battery energy storage system, and in the background you've got a smaller 40 kVA generator. For this scope that we're looking at just here, the generator runs very intermittently, and the purpose of the generator is to provide a charge to that battery system. This has given significant reductions in fuel usage. And where, if you were looking at a 1,000 litre tank, for example, you might see that generator requiring 1,000 litres of fuel per week, whereas with this battery setup, that's kind of decreased the fuel requirement, and we're now looking at 1,000 litres lasting approximately 7 to 8 weeks, depending on the usage. So I think that is definitely going to become a lot more popular. I think there is still more to do with how we look at it. I think in previous slides I've shown you pictures of a nice kind of stacked compact setup. At the moment, that when we're looking at these hybrid solutions, we're looking at a number of different components, and I think there's a little bit more work to go with the kind of best way to offer that as a setup. And then also we've been talking to our suppliers and also some of our customers to look at hydrogen. I think again we're probably a little bit off hydrogen generators being deployed out on turbines. However, we are in talks to do an onshore test with a hydrogen generator paired with the battery setup to really, I guess, prove the idea and see how we can go. But there's certainly a lot of questions as to how we would kind of manage hydrogen in an offshore environment. But I think it's important that we are looking ahead, and it's important that the industry looks ahead to see how we can continue to deliver temporary power with minimal impact to the environment as well. So thank you all for your time. If you do have any questions, I will be available on the stand, or I can give out any business cards, and you're welcome to contact me via email. Thank you so much.